Question 5. A bowling alley manager in the UK is concerned about falling revenue. He collects data, blah, de blah, de blah. Okay, what have we got? We've got a scatter diagram and we've got a product moment correlation coefficient. Okay, so that's our PMCC value at minus 0.7617. So is it looking like negative correlation? He carries out a one-tail test at the 1% level of significance and concludes that the higher margarine consumption is associated with lower bowling alley revenues. I mean, those are two ridiculous things to try and correlate, but that's what we're supposed to be doing in this question. So part A, show all the working for this test. Okay, so we've basically got to carry out the test and show how the numbers mean we come to this conclusion. Okay, so H0 and H1. So this time our symbol is the rho symbol. It's not mu and it's not a P for probability. Okay, rho equals 0, no correlation. Okay, and then H1, it's a one-tailed test and we're looking for a downward negative correlation, so it's going to be rho is less than 0 as our H1. Okay, so again, you've got to basically state your hypotheses with the symbols to be sort of sure that you're going to get your marks. So what do we know? We know that N is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Didn't actually tell us that anywhere in the question, but we can count the dots. We know we're doing a one-tailed test. We know it's a 1% significance level. And we know our test statistic, that's the value of the PMCC for those 10 dots, and that will be given to you in the question. So that's minus 0.7617. So all of that we know. The only thing we have to look up in your tables is the critical value. I'll just get the tables and show you how that bit works. Okay, so you have to go to the product moment correlation coefficient, which is in here somewhere on the next page. Okay, so make sure you're looking at the right page because that one also says correlation, but that says Spearman, so you want this one, product moment. Okay, and all we have to do is find the correct column. So it was a one tail 1%. So one tail 1%, so we're coming down the fourth column. We're coming down as far as N is 10, so it's the one I'm pointing at here, 0.7155. Okay, that's our critical value. Take that and just copy it into your workings. Now, because we're comparing it to a negative test statistic, we're going to just insert the minus sign in front of it. Basically, they don't print two tables, one for pluses and one for minuses. So you just put a minus in front of it if your test statistic is also minus. Okay, so basically we now need to ask ourselves, is our test statistic beating the critical value? Is it big enough to show that there's correlation going on? In this case, negative correlation. Okay, yes. It is. I'll draw you a little number line so you can see. Your correlation goes from -1 through 0 to +1. So we're looking at the lower end. Our critical value there is at -0.7155. From that value to the end is what we call the critical region. Okay. Once you've established that, you then think, where does my test statistic fall? And it falls into the critical region this time because it's closer to the end at -0.7617. Okay, so because our critical value is basically not beating the test statistic, I'll say that the other way around, the test statistic is beating the critical value, that is enough for us to say reject H naught, okay, and it seems likely that we do have negative correlation. Okay, because remember H naught was that there isn't, it's not big enough to beat the critical value, but here it is. So our conclusion is because our test statistic beats the critical value, we can reject H naught. Or you can say because the test statistic is in the critical region. Maybe that's a better way to phrase it, but doesn't really matter as long as you plump for the right conclusion. We reject H naught and conclude that there is negative correlation between, and then make sure you go back to the context, so it's between the margarine consumption and the bowling alley revenue. Okay, that's how it works.